The trick with these is first just to figure out which method that do you have, what tools in your toolkit do you have to solve this. Well, here, across from here, this is the hypotenuse. Here's the angle you're interested in, so this is the adjacent side, and this is the opposite side. And you've got the x is here, and you got a 17 here, and you got your angle here. Adjacent and opposite, that would be tangent. So the tangent of 38 degrees is equal to the opposite over the adjacent. So that means you want to multiply 17 times the tangent of 38 degrees. And if you do that, you get 13.28. And that's the answer for that. Okay. If you move to this one, you have the same kind of situation. You've got an angle measurement. You've got the hypotenuse, which is over here. You've got the side that is adjacent to it over here, and the side that's opposite to it over here. Okay. So again, it's opposite and adjacent. The tangent of 17 degrees is equal to the opposite over the adjacent. So if you multiply 15 times the tangent of 17 degrees, you should be able to get x. What my calculator says is 4.586. Okay. So we're on a roll here. We seem to have the same thing over and over again. We've got an angle measurement over here. The hypotenuse is here. And that's where the x is. We've got 14. This is on the opposite side. Opposite and hypotenuse, that would be the sine. So the sine of 32 degrees is equal to the opposite over the hypotenuse. When you get this situation, you can switch the numerator here and the denominator over here. So you wind up with x is equal to 14 divided by the sine of 32 degrees. And when you do that, I get 26.419. Okay. The one underneath this one is a slightly different kind of trig problem, because you're being asked to find the angle. And you're given all of the numbers. How cool is that? That means it doesn't really matter which of the different sine, tangent, cosine, trig functions you use. You have enough numbers to fill in any one of them. Take your favorite one. Okay. Let's do cosine of theta is equal to 20, because that's the adjacent, over, right, 52, because that's the hypotenuse. That means that the inverse cosine, if you're doing it by calculator, of 20 over 52 is equal to theta. Just quickly figuring out what this is as a decimal, 20 divided by 52, this looks like it's 0.3846 blah 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 equal to theta, and the inverse cosine of that is 67 degrees. And you can either find that by looking down the chart to find the one that's closest to it, or some other way, right, using a calculator. Just for fun, let's just double check, because the tangent of theta degrees should equal the opposite over the adjacent. So that would be 48 over 20, which means the inverse tangent of 48 over 20 would be equal to theta. 2.4 is what that becomes as a decimal. So if you were to do that, 2.4, and then get the inverse tangent of it, it's 67 degrees again. Okay? I don't need to do it a third time to be sure. I'm okay with that. So the answer to this one is 67 degrees. You need to be able to find the angle as well as find the side in order to pass the trig part of this standard. Now, of course, this one right here, there's no angle involved in this at all. Now, I didn't draw it very well, but this is the right angle over here, and that makes this the hypotenuse. And that means that x squared plus 5 squared is equal to 14 squared, which means x squared plus 25 is equal to 196, which means that x squared is equal to 171. Oops. Need to go over here like this. Which means that x is equal to the square root of 171. And I can't put a 2 into that, but I can put a 3 into it. So let's see what happens. This would be 57. I can put a 3 into that too. That's 19. So basically this is 3 square root of 19. That's the answer. Unless you see the number 60 or the number 30 or the number 45, you don't have special right triangles. But if you do, then you do. Here, for example, you have 60 degrees here. It's a right triangle. The side opposite the 60-degree angle is 9 square root of 3. In order to get the side that is opposite the 30-degree angle, you take this and you multiply it by the square root of 3 over 3. And that turns out to be 9. So this is 9. And whatever this is, this has to be twice as big. So this is 18.
How do you simplify where it says y?
This?
Yeah, how do you simplify this?
Well, square root of 3 times square root of 3 is 3. Divided by 3 is 1. Okay. Here, looks like we've got that same thing. This is the 60-degree angle. This is the side across from the 60-degree angle. So in order to find out what this is, we have to take that number and multiply it by square root of 3 over 3. Whoops, too many little thingies there. Okay. Which means this is going to be 7 over 2 times 3 over, and times 3 on the bottom, right? Square root of 3, 3. So we're going to just divide that out. And this will be 7 over 2. The hypotenuse has to be double the side across from the 30-degree angle. That makes that 7. Now for both of these, if you remembered that whatever this is, you multiply it by the square root of 3 to get this, that makes this even easier. Because what did I multiply by the square root of 3 in order to get this number? 9. What did I multiply by the square root of 3 in order to get this number? 7 over 2. But even if you don't remember it, there are plenty of clues here. 7 square root of 2 over 2, when you have the leg of a 45, 45, 90, and you want the hypotenuse, you multiply it by the square root of 2. And that gives you 7, because square root of 2 times square root of 2 is 2, divided by 2. And that also makes sense, because if you have a number here, what do you have to multiply it by to get the leg? Square root of 2 over 2. So once you see that, it's like, yeah, this is all starting to make sense. This one's easier, because you've got the short leg, and that's the easiest way of all. The hypotenuse has to be twice as big as that, and then this has to be that number times the square root of 3. And here, you're given a 45, 45, 90 triangle. You're given the hypotenuse, and we just said that in order to get the leg, if you have the hypotenuse of a 45, 45, 90 degree angle, you have to multiply it by square root of 2 over 2. Okay, this was the volume portion of the test. One of the questions was to get the the volume of the cone. And the volume of the cone is equal to 1/3 the area of the base times the height of the 3D shape. So what have we got here? The area of the cone, you're given the diameter, but what you really need for the area here is the radius, and that's 4. So this is, the volume is equal to 1/3 times pi r squared times the height. So the volume is 160 divided by 3 pi miles cubed. That's all you had to do. For the sphere, again, you were given the diameter. What you needed was the radius. I believe the volume formula for this, and you have it, I think, 4 divided by 3 pi r cubed. Isn't that it? Which makes this volume is equal to 4 times 4 cubed over 3 pi. And 4 times 4 is 16, and 16 times 16 is 256, I think, divided by 3 pi. And this was inches cubed. In other words, it's just a question of plugging the numbers into the equations. Forgive my drawing, but basically, even when you have a prism, the volume here is equal to the area of the base times the height of the 3D unit. The height here is 12. The sides are all 10. And the apothem here, which is the height of the triangle here on the bottom, is 8.7. So the volume of this was the area of the base, which was 6 times the area of this triangle, which is 1/2 times the base times the height of the triangle times the height of the 3D unit. So it's a little bit of arithmetic here. This makes this 3 times 87 times 12. 87 times 36. 3132. 3132 meters cubed. Okay, so the first question here is this a pair of similar triangles? if you take the larger one on this triangle and compare it to the larger one on this triangle, it's 156 over 48. Let's see what happens here. 156 over 48. And then the question is that equal to 91 over 28? If it is, then we have two pairs of sides with the same ratio, and since these are vertical angles, we have side angle side. If this turns out to be the same thing. So let's see. I'll just cross multiply because I have a calculator and that makes it easy. 156 times 28 is 4368. And then 48 times 91 is 4368. So this is true. That means this is side angle side. Now, how do you write how do you write this? Well, let's see. Let's start from the center and go down the long leg, EML. Triangle EML is similar to triangle. Start from the center, go down the long leg, EFG. Or anything that matches that. All right. Here, let's see what we got here. Put this triangle here. Do we have enough? We have this side length, the whole thing, this and this. We have enough numbers to find out whether it's side, side, side. We also have enough, since we know that this angle here is congruent to itself, we could do side angle side. Side angle side would look like this. 30 over 70. Is that equal to, let's see, if this is 24 and this is 42, this has to be 18. So it would be 18 over 42. I can divide both of these by 6. I get 3 over 7. And I can divide both of these by 10. So it is, right, by side angle side, similar. And just to double check, 63 over 27. I'm going to divide top and bottom by 9. This is 7. This is 3. So you get the same ratio that way too. So whether you did it by side, 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 or side angle side, it's still good. And what have we got here? RST, that's from here to here to here. That's going to be similar to RBA. Okay. Looking at these, well, the only way we can do these is with side, side, side. So let's take the bottom one, large, medium, small, and then take the top one, large, medium, small, and just quickly go to our trusty calculator, because we can. 117 divided by 36 gives us 3 1/4. 105 divided by 32 gives us, let me just double check to make sure I did that right. 117 divided by 36, 3 1/4. 105 divided by 32. Yeah, these are not similar. because they don't have the same ratios. That one's easy. Let's see what this one does. This is like the first one. We have two vertical angles and then sides we can use. The large one here is 72, and the large one here is 27, and the small one here is 64, and the small one here is 24. And again, let's just jump right to the calculator. 72 divided by 27 equals 2.6 repeating. And 64 divided by 24 equals 2.6 repeating. So we have side angle side here, and triangle FDE is similar to triangle LDK. Is that how they ask it? No, DEF is what they ask. So this way, DEF, the center down the small side, so we've got to do DKL to get the similarity statement for this one. Questions? Okay, so we have this question here. Triangle CBA is similar to triangle CVW, and we've got some side lengths. We want to try to find X. So what do we know? We know that VW compared to BA has to be equal to CV compared to CB. Right? CV and CB, VW and BA. So over here, BA is 3x, VW is 18, CB over here is 35, and VC over here is 30. I'm going to just quickly reduce these. 6 over x is equal to 6 over 7. Right? Because if I divide top and bottom here by 5, I get 6 over 7. If I divide this by 3, I get 6, and that becomes a 1. So 6 over 7 is equal to 6 over what? Oh, come on. 6 over 7 is equal to 6 over what? 7. That's the answer to that question. Again, this is one where you're given two triangles that are similar. The question is, what can you do with it? We have LJ. That's got to match with CJ in the other one. And we have KJ. That has to match with JB in the other one, right, because of this. So LJ is 70, KJ is 98, JB is our variable here, and CJ is 20. Well, I can reduce this. This is 7 over 2. Okay, so 7x equals 2 times 98. X is equal to 2 times 98 over 7. 7 actually divides into 98 evenly by 14. So the answer here is 28. In order to be able to pass this standard, right, you have to be able to find the missing lengths, but you also have to be able to do a two-column proof. I gave you a choice of which pair of triangles to do a proof for. There were 3 of the 4 that were similar. You could have done any one of those. Let me just quickly go through each of the different proofs. If you chose number 14, this was the situation. you had these things that were given. And I wrote them small and large, with one triangle on the top and the other triangle underneath it, so that I could quickly and easily say GE over EL is equal to FE over EM, which was 13 over 4, and that's just proportions. We also know that angle FEG is congruent to MEL because they're vertical angles, and since we have two pairs of sides with the same proportion, and those two pairs of sides create congruent angles, we have side angle side congruency. I'm sorry, side angle side similarity. For number 15, this is what you were given, and it's not exactly what you needed because you were missing the side length AR. But you could figure it out because you knew what TR was and you knew what TA was, right? So if you know that this is TR and you know that this is TA, if you take this length and subtract this length, you're going to have this length. That's segment subtraction. So we got that. Then we have enough so that we can make ratios out of all three sides. And it turned out that 7 over 3 was the ratio you got, so that was proportions. And that made this side, side, side similarity. The other way to go about it, you still needed to do the segment subtraction to get AR. But if you used just TR and RS, didn't use this, just said those two were true by proportion, but then you said angle R is congruent to angle R because of the reflexive property, then that still would have given you triangle RST is similar to triangle RB A, but this time it would have been because of side angle side similarity. Okay, so there were two ways to do this one. Okay. Number 16, the triangles weren't similar, so if you picked that one to do, you sort of messed yourself up completely. For this one, for number 17, you were given 4 side lengths. That's what was given. If you set them up in proportions, the two pairs of corresponding sides had the proportion of 8 over 3. There were 2 vertical angles that were made up of the side lengths that were proportional, and that means you had 2 triangles that were side angle side similar. The next question had to do with 2 3-dimensional shapes. These were edge lengths. One was 90 on one of them, and the corresponding one was 36 on the other. 80 and 32 corresponding. If you take either one of these and divide by the other, whether it's 90 over 36 or 80 over 32, 80 over 32, you can divide top and bottom by 8. You get 10 over 4, and that's the same as 5 over 2. So the scale factor between these two shapes was 5 over 2. And so you were asked for the scale factor, which is for the linear measurements. Then you were asked what would the ratio be for the area and what would the ratio be for the volume. And this is what we went over a couple of times, and I kept telling you this is counterintuitive, you're going to have trouble with this, and some of you did. But if this is 5 over 2, this is 25 over 4, and this is 125 over 8, because this is 5 squared is 25, 2 squared is 4, 5 cubed is 125, 2 cubed is 8. Those were the ratios that you needed to write down to get this answer correct. Yep. It's that simple. That's fine. You can do long stuff if you want. You could have, if you wanted to, found the area of one of the faces and compared it to the area of a corresponding face, and you would have gotten this ratio. And if you could have figured out the volume of the first one and compared it to the volume of the second one, you would have gotten this ratio. But that's the rule. Okay, the last bit was about area. These two, although you can't tell from my drawing, are regular polygons. This one has 3 sides, this one has 7 sides. The perimeter here is 24, which means each one of these sides is 8. Okay. If I draw, well, actually, what can I do here? It's an equilateral, right? I can just drop this here. This is going to be 4, isn't it? This is a special right triangle. This is going to be 4 square root of 3. Right here. So 1/2 the base times the height is 16 square root of 3 units squared. It's probably the easiest way to do it. Here, we have to take one of the central angle triangles. Okay. This is 6 meters. This angle right here is 360 degrees divided by 7. It's not a pretty picture. And then when I cut it in half, it's going to be 360 degrees over 7 times 1/2. That's 180 over 7. So let me just quickly come in here and see what that turns out to be. 180 divided by 7. Well, that's kind of annoying. But if you have a calculator, it shouldn't matter much, because whatever this angle is right here, you know this side is 3, and you know the tangent of this is opposite over adjacent, which is what the height is. So the tangent of that angle we just found is equal to the opposite over the adjacent, which means that the height is equal to 3 divided by the tangent of that angle. So I can actually do that this way. Okay? And if I want the tangent of that, with this calculator, I have to push the tangent button. That's the tangent of that angle. Okay? So maybe I'll just write that down. 0.4815744619. And then say, what is 3 divided by 0.4815744619, and find out that it is that number there. That's the height of this triangle. Now, if I multiply that times 1/2 of the base, be multiplying that by 3. And since this is a regular hexagon, if I multiply that times 6, I get 112.132 meters squared, and that's your answer. Here are two triangles, one with a base of 9.1, the other with a base of 2.5. Both of them have a height of 5. So 1/2 times 5 times 9.1 plus 1/2 of 5 times 2.5. Well, once again, it's good to have a calculator. 9.1 times 5 divided by 2 is 22.75. And what else have we got here? 5 times 2.5 divided by 2 equals 6.25. If I add 22.75 to that, I get 29. So the area here was 29, what were they, meters? Meters squared. 29 meters squared. Okay. This triangle, which was the next problem, is just easy if you turned it on its side because you've got the base and you've got the height. So 1/2 times 8 times 5.6 is 4 times 5.6, and 4 times 5.6 is 22.4. And that was yards squared. Okay. And then finally there was this composite shape where this distance from here to here was 18. From here to here is 4, and from here to here is 4, so that makes this 8. That means that the area of the entire rectangle is 8 by 18, or 144. Then you have 4 triangles that have a base of 4 and a height of 4. So you have 4 times 1/2 times 4 times 4. And that's how much you're cutting out of this. So that's 4 times 4 is 16, times 2 is 32. So if I take 144 and I subtract 32, I get 112. And I think it was just units squared. Was it inches? Thank you. Inches squared. There you go. That was the whole test.